All right. Next topic up here is going to be on acids. So we skipped over one earlier when going through this. We were going through naming the cation, and we said the first one was, does the cation of metal go to 5? But the second one is, if the cation is hydrogen, go to number 9. Hydrogen is sort of special. Whenever you have a molecule that has hydrogen as the cation, then you normally have what's basically called an acid. This is the very definition of what an acid is. An acid is a molecule, is a chemical, where the cation in the molecule is hydrogen. And the only real exception to this is that acids are generally considered to be acids whenever they're dissolved in water. Technical term for this is in aqueous solution. And so if you have a molecule which is cation is hydrogen and it's an aqueous solution, it's always called an acid. Sometimes if it's dry, the hydrogen is treated like a metal, and it's using the same system we've been using before. But normally the rule is, if you got cation, it's hydrogen, it's almost always going to be an acid. And so going through this, we got to number 2. We said, is the cation hydrogen? And the answer for these acids, we say yes. So we go to number 9. And it says, as we said, compounds with H as their first element are generally named as acids, especially when in aqueous solutions. However, if they're dry, pure compounds, they may be named as if hydrogen were a metal. Go to number 5. So if we're assuming this is aqueous solution, the way of writing that out, if you ever do have something that's an aqueous solution, works sort of like this. If we have hydrochloric acid, HCl, if I wanted to show for certain this is an aqueous solution, what I would do is afterwards, in parentheses, I would put AQ. Anytime you see that AQ, that's what's called phase notation. When you put something in parentheses afterwards that's after the symbol like this, what it means, it tells you whether it's a solid, liquid, gas, or dissolved in water. And solid would be S, liquid would be L, gas would be G. AQ in parentheses means that it's going to be dissolved in water. And so this is how you'd write out aqueous solution. So this would definitely be an acid right here because it starts with hydrogen, that's its cation, and it's an aqueous solution. For the purposes of this class, unless I tell you it's a solid or a gas in that phase notation, assume any molecule that starts with hydrogen is going to be an acid. So, that being said, taking a look a little farther here, we jump down, as it says, to number, we're already on number 9, we finished this, so we just go to number 10. So, the second part here, binary acids. If there are only, and this is number 10, if there are only 2 elements in the acid's formula, it is a binary acid, and its name is based solely on the non-hydrogen element. The key here in the word here is the word binary is the bi. Bi means 2, and so it only has 2 elements in it. And so, in this case, the name will start with hydro and end with a modified name of the other element. This example that we gave up here a little bit before, we talked about HCl. So the first part you say here is, okay, is that if I'm trying to name this, I know it starts with H. That means it's going to be an acid. And so I know it's going to be an acid right here for this guy right here. The second part we said is that since it's a binary acid, it only has H and it only has Cl, so only 2 parts to it. Then the name, as it says, will start with hydro and end with the modified name of the other element. And so we know this is going to start with hydro. Oftentimes people think that hydro means water. In this case, it does not. All the hydro means is that it is a binary acid. It's an acid that has hydrogen and only one other element. So we say hydro, and in this case right here, it ends with the modified name of the other element. The ending of the name of the other element is replaced with ic acid. So Cl is chlorine. So we drop the I in E and add ic acid. So we come up with hydrochloric acid. If I can fit it all in here. So hydrochloric, and that really didn't fit very well. It's hydrochloric acid. All right, that looks absolutely hideous, but this is basically what we end up with on here, is that when you name this out, you end up with hydrochloric acid. Okay? And so that would be a classic example of a binary acid. Another binary acid you might run across would be something like, let's suppose that we have H3N. In this case, is that we say, is this an acid? Yes. Cation is hydrogen, so we know it's an acid. Second question we say here is this binary? Yes, it only has 2 elements in it, hydrogen and nitrogen. And so it's a binary acid. We know it will start with hydro because of the fact that it's binary. And it'll end with a modified name of the other element. The other element here is nitrogen. And so we will drop off the gen and add ic acid. So in this case, this becomes hydronitric acid. And so hydronitric acid is what we have for this guy right here. So hydronitric acid, Nitric acid, will be the name of H3N. So hydronitric acid. But suppose that we do not have something which has only two elements. We have something that has more than that. Like, for example, that what if we were given something along the lines of H3PO4? H3PO4. So we go through, we say, first thing is the cation hydrogen. Yes, most definitely hydrogen. And so that means it is going to be an acid here. And so then we go down and we say, does it have only two elements? This is number 10. If there are only two elements in the acid's formula, our answer is no. This has three, hydrogen, phosphorus, and oxygen. It has a polyatomic ion. So we go to number 11. It says if the acid involves three elements, it's called a ternary acid. Tern is basically three. Is basically the root that's there. And so it has three acids. It's called a ternary acid, and it's named for the polyatomic ion produced in the aqueous solution of the acid, basically that it splits up. And so the key here when trying to understand ternary acids is we need to look at the polyatomic ion. In this case, it's PO4. Now, the way this works is if the name of the polyatomic ion ends in "ite," the acid will end in OUS acid, us acid. If it ends in "ate," it'll end in ic acid. And so we have to look at what PO4 is. And since it's a polyatomic ion, we look on our polyatomic ion sheet, and we see that PO4 is phosphate. Since this is phosphate, ends in ATE, we'll change the ending of phosphate, we'll drop the 8, and add ic acid. So this becomes phosphic acid or phosphoric acid. Either one works. So phosphoric acid. So phosphoric acid here, because of the fact that it has, as the root here, it has phosphate, and so because of the fact that it's 8, it's going to be ic acid. So the ic acid means it's 8, and then the phosphor comes from the first part of that PO4. And so at this point, you're done with the name. That's all you have to do.